This lesson is about graphing linear equations, but instead of using tables, we'll use a different technique. We'll actually use the intercepts to help plot the graph. So the first thing we need to talk about is different forms of linear equations. This is called standard form. Standard form has x's and y's on the same side, where a, b, and c are all integers. So there's a big difference. In the previous lesson, we looked at graphing equations of lines using a table of values, which is easy to do if you have y by itself. But in this case, it is not. X and y are both together. Let's look at this first example. This would be fairly difficult to do using a table of values, and that's because this equation is in standard form. We'd first have to get y by itself. So in order to avoid that, let's go ahead and use the intercepts. I'm going to set up two separate workspaces, a space for the x-intercept and a space for the y-intercept. Since the x-intercept is the place where the graph crosses the x-axis, those points, or that particular point, is going to have a y-coordinate of 0. You won't go up or down at all, just staying right on the axes. So that's how you do find the intercept. We're going to go ahead and put a 0 in for y. I'll have 2x minus 3 times 0 equals 6. We know that anything times 0 is 0. So you're left with just 2x equals 6, or x equals 3. This is the x-intercept. Its ordered pair is 3, 0. And it's right here on the graph. Let's do the same thing for the y-intercept. In this case, I'm not going to go to the right or left at all. I'm just going to go straight up or down. So that means x is 0. 2 times 0 minus 3 times y equals 6. The 0 part goes away. And after dividing by -3, we get y equals -2. This is the y-intercept. Its ordered pair is 0 for the x-coordinate, -2 for the y-coordinate. Right there it is. Since we have 2 points, that's enough to make a line. So right there it is. Let's look at another one. In this one, we have x plus 2y equals 4. Once again, it's in standard form, so it makes sense to actually use intercepts to plot this. So let me go ahead and set up my workspace. For the x-intercept, the y-coordinate should disappear. It should be 0. So I'll have x plus 2 times 0 equals 4, or just x equals 4. The ordered pair is 4, 0. It's going to cross right here. For the y-intercept, x has to be 0. For this part, after dividing by 2, I'll get y equals 2 for the y-coordinate. The ordered pair is 0, 2. It's right here. Let's go ahead and draw that line right through those 2 points. And like I said, this works great with standard form. Here's an equation like we saw in the last section. It's not in standard form. That doesn't mean you can't do the intercepts, but some tricky things happen. Let me show you what exactly happens for this one. Let's start in the same way. I'm setting up the workspace for the x-intercept and the y-intercept. For the x-intercept, that's when we make y equal to 0. After dividing by 2, we find that x is 0. So I have 0, 0. The origin must be the x-intercept. For the y-intercept, I'm going to make the x be 0. And we find out that we have the same point. The x and y-intercept are exactly the same. We can't draw a line, but I know a line exists. What that tells us is this method of finding the x and y-intercepts is not good enough. We can't use it for this particular problem. So I'm going to have to resort back to my table of values to find a couple more points. So we already used 0. Let me just do a couple more, like maybe the point x equals 1. When x equals 1, we have 2 times 1, or y equals 2. Even though that's enough, let me do one more point. When x equals 2, we have 2 times 2, or 4. Now I have some more and enough to connect the dots. Let me go ahead and put my line in there. There it is, and we're able to fix it up. So if you get to a problem, it's not in standard form, you can use a table of values, or you can attempt to do the x and y intercepts at least to get a couple points. Either way, you're going to be able to find the equation of the line.